Hi friends, today let's look into the internal developer platform IDP. So there are a couple of videos, but let me explain what is this internal developer platform is. Currently we are working on DevOps, so we have to see what is difference between internal developer platform and the DevOps is. Okay, by the word says it is a platform for developers. Okay, when we say internal, it is for internal applications, maybe your company or maybe for your application. Take, for example, Facebook or Flipkart. So, if you are developing Flipkart, which is an internal for Flipkart company, they provide this application for others, right? So, when we say internal, it's just for a company or a team, developer platform. So in a company, in a team, you have set of developers. For them, this platform will help. And currently we are into DevOps. What DevOps is doing? DevOps is focused on time to market, how much you can release the products, how fast. So DevOps starts with Git. After Git, it will go to build. After build, it will deploy or test and deploy. It depends, right? So consider you have your code in Git, you do build in GitLab or GitHub actions, then you deploy it to AWS or Azure. So when you say deploy, you also have different environments, which comes under dev, test, and prod. So these are environments. Okay. So during your code and build, you also have to do unit testing or scanning, security scanning for your images. When the build is happened, there is a security scan on the image. So for deployment, you have to learn Terraform or CloudFormation, which basically infrastructure as a code. To make this build to work, you use a YAML configuration. It can be GitHub Actions or it is GitLab. Basically, you need to have configurations to build the code. And as a DevOps engineer, some are providing these tools for in your environment. They provide the various tools for you, and finally you will deploy into AWS. So as a developer, I have to have knowledge on all these different stages and different process to release my application in an environment, to test it and go to prod. Think this all this has been handled by a platform, and I don't I just work with Git and then I commit. Rest is done, taken care by platform. Then your work is so easy, right? You once you deploy, say there's a platform here, and your code is deployed. Now you go to your URL or it is a API, your endpoint, test that your feature is good. If you made a feature in UI, go to the application is already deployed in your whichever environment it is, dev, test, prod, and you will see a endpoint or URL to test. In between, if the application is failed in security or testing or something, your application is not deployed, whereas it notified you again back. Not in Git, but that notification need to be somewhere in the UI or CLI. So we need to have a UI or CLI. For example, when you are deploying as a platform, now you are going to do some deployments manually. So what happens version 1, 0.1 you deployed automatically, version 0.2 you did manually, version 0.3 you do it manually, 0.4 you did automatically. So what this platform can do or in your DevOps practice, if you deploy a version and it fails, it should automatically roll back to your previous version so that the application is still up and running and you can go and fix your bugs in the version you deployed. So here, if you see, I automatically deployed version 1.0 and this 2 manually. Now, if I roll back, my system only knows 0.1 because you deployed 0.2 manually, 0.3 manually, and 0.4 automatically. Even though it rolled back, it rollbacks to the version where the system is deployed. It doesn't know what you have deployed manually. To avoid this, everything need to be automated. Like everything should go in an automated way. You should not bypass this. And the platform itself should be built with the capability of no having that. That is where when we talk about IDP, we will also talk about something called control plane. And this there is a product for control plane is example is cross plane. So for the deployments, instead of using infrastructure as a code, you have infrastructure as a code deployed to control plane. What happens now? So when you do something manually, so when I deploying 0.2 manually, the control plane will have a sync, and removes that deployment, and it again deploys 0.1 based on the Git. So whatever you have in your Git was your desired state. Like what is your application is desired to do, like desires. What is running in your environment was your actual state of your application. So your desired state will grow day by day. Your features, you have a desired development, but your actual state is what you have deployed and what is showed to the users. So this control plane will always sync between your desired states and actual state. So if you want to do some changes to your deployment, you change in the Git, and control plane applies that to your actual state. They both, whatever is written in your Git and whatever is deployed, you should be in sync. This is called as GitOps principles. GitOps principle. So right now we are talking about GitOps, GitOps principle. What GitOps says is everything is based on Git. Every changes should be tracked from your Git, and you should not have manual process all this here. So developer has everything on the code or everything in his repo. Okay. So now try to understand you are eliminating all these things manually, and you have what you are doing here is you are creating something called pipeline. So what pipeline does? Pipeline is just the automation where when your code is committed, it does the build. When build is successful, it goes and deploy. But there are different things involved here in your pipeline. One is your build stage where it will run your npm or Docker build, and the Docker will be stored in Docker Hub or ECR repository. Once your Docker build is done, then your Terraform or your cloud formation needs to pick the Docker image from the ECR, and then it deploys to your AWS environment. And in AWS, you may use ECS or you may use Lambda. So it creates the Lambda infrastructure, and then it creates the ECS infrastructure, and it deploys the image into it. So all this process are made in the pipeline for each and every repo. For each and every application, for each and every repo, you will have this pipeline in DevOps. Whereas internet developer platform, think about you have 50 applications, you are managing 50 pipelines, correct? So because each repo has a pipeline, and every pipeline have to be managed. So I want to introduce some kind of scanning. I have to introduce that somewhere in the GitLab or GitHub, but I have to add that in the build file, or I need to add that configuration in my the CI file pipeline. Basically, I have to add in the all the 50 repos, and some can do different way. Here, there's a question of standardization also. Each application, when you deploy, someone can use ECS, someone can do EKS, Kubernetes service, someone can use EC2, right? Because on the end, it could be your Java or your Python or your Go language. Doesn't matter, it's a website or it is an API, it is the code. It is a Java code. But there are certain architectures to it. If it is an API, you need an API gateway, right? And if it is a application which need security, you need a security tool basically. So internal developer platform, the DevOps engineers obviously will work on this, but they will have this same tools, set it up with the help of control plane and with the user interface. So developer will come to this user interface and he will uh, create a new application, and all this will be provisioned automatically and control plane will make the deployment. So I hope you understand. Instead of having a different set of tools where I have to configure and play around, it is a most time consuming task where I also have to create AWS account and wait, do all this stuff. But platform does has everything readily available, and developer just comes and do everything himself, which we call it a self-service plane. When we say control plane, AWS console itself a control plane where you go and create your EC2 mission, or Azure VM, that is a control plane. It's a self-service. You go, you create. But in the organization, there is a lot of access control and request mechanism. If you want to get an AWS account, you have to make a request or a service now or some ticket to your team, and the team have to provide you. Right? So there are a lot of different problems here in current thing where we struggle with access and request and make sure this all work together without breaking. And when we do some changes, it should not affect all this. So, but platform will help developers in a great way. That doesn't mean you are moving out of all this DevOps concept. You are still there, but whereas the platform will handle it, and whoever worked on this going forward, you will be working as platform team or maintaining this platform or building more features to this platform itself. I will explain more in the next video about what kind of UI, what kind of control plane, and so such thing. I hope this clarifies little bit about our next journey in automation from DevOps to internal developer platform. So you can skill yourself reading more into this, where I can also share more knowledge on this. Thank you guys. See you in the next video.